All right, Crouton and Ramon's House of Math. Turn the microphone up. I'm pretty sure you can hear the AC in the background. I'll run it for like a half an hour. Yep, we went live. Crouton and Ramon's House of Math. All right, let's play with some third power algebra. And you Montessorians, pay attention. Because when we go to fourth power, you guys fail. You fail to give understanding, you fail to give teaching. All right. Fourth power would be using the big blue square. But we're not going to do fourth power. We're just going to stay in 2 dimensions and do third power algebra. And any little child can do this. I set it equal to anything. We're just going to play with it. All right, so let's see here. Could we factor this? Could we factor out an x plus 1? I believe we could factor out an x plus 1. And if I factor out x plus 1, then this is the same thing as x plus 1 across and x squared plus x plus 1 up. You're looking at this over here. Any little child can do this. We're going to stay in 2 dimensions. We're not going to bust out 3 dimensions. Because when you start doing 3 dimensions, it becomes difficult. And then how are we going to show the fourth power? Explain to me how you're going to show the fourth power using your little boxes and stuff. Answer is you're not. By the way, this information, and well, the negative part of it and more, is actually trademarked. But anyway, all right, so now let's say, and see, this is the other thing. Most other guys out there, one, they're not showing this to little kids, and two, they can't even get the across and up together. And the across and down, now we're going to do division. So now I'm going to ask, and you're going to be able to see it, how many x plus 1s are in x to the third plus 2x squared plus 2x plus 1? Let's see what we're doing. We're playing with these pieces. Playing with these. Playing with these guys. I'm not even doing a 3-period lesson because I'm just having fun here. You want more? Go to my math site. Go to my website and we'll get you more. Allegedly advanced algebra. Any 5-year-old child can do this. And yet, this has stopped more than a few women I know from becoming nurses. More than a few women I know from getting into engineering because they failed algebra, because stuff like this just didn't make sense. All right, I can look at this and I can see if it's x plus 1 across, well, then it's x squared, x and 1 down. Oh, I'm in trouble because I didn't show my work. So let's show my work. What's x plus 1 x squared times? Well, x plus 1 x squared times is this and this is x squared. It's x cubed and an x squared. I'm multiplying this times that. In fact, let's get rid of this right here. Again, any little child. When we first start off and we do the vertical alignment and the scaffolding that you guys talk about, the child is just going to count. And we're not going to talk about multiplication. Anyway, there's a methodology here, believe it or not. And there is an x squared. And then what? Then we got to take all of that away. And what's left? This right here. Okay, so this line is that line right here. This line and that line, same line. So here I'll use a different color line so you can see the next line. And the next line is going to be right there. All right. So in the meantime, I got to multiply x plus 1, that's this, by x. So when I do that, I'm going to have another x squared. Oh wait, I got to subtract, so I got to count what's over here. An x squared plus 2x, I'm counting everybody, 2x plus 1. Okay. That's this right here. There's x squared, 2x plus 1. Oh, you see it? All right, we just got bigger. That's all it is. All right, so now I'm going to multiply by x plus 1 by x, and I'm going to wind up with x squared and an x. And I got to take that away. Oh, wait, I got to make this line purple so it matches up. So I want to hear it from people. Oh, it's so hard. Oh, the math is so hard. This is third power algebra, and it's easy. And guess what? The calculus. Guess what? The trigonometry. Guess what? All of it. And no, I can't teach it to you in 5 minutes. It takes a while, which is why right now, I know what you're thinking. You're thinking, oh, when he says there's a week's worth of videos at McRae's page, you mean that, oh, I could watch a video an hour in the evening for 7 days in a row, right? That's a week's worth. No, it will take you 40 hours to get through McRae's. But actually, it's going to take you like 45 hours if you watch every video on his page. That's a week's worth of videos. In other words, you're going to watch 8 hours a day for 5 days. No, you're not. What you ought to do is watch some videos, a few hours a week. Not a few hours a day, although I know there's some of you doing a few hours a day. I can tell by my web data. Anyway, okay, so there I am to there. What's left down here? An x squared plus 1, right? Even if I'm just counting, I don't know anything. I don't know nothing about subtracting because I'm 5 or 4. But I know this one is called an x to the third, that one's an x squared, that one's an x squared, that's an x, and that's a unit. I can identify the pieces, I know their names, and I can have a fun time and start doing crazy math. Oh no! Right? My sons, when Julian Marcus and when Ben Isaiah were like 4 and 5, was this hard? Was I robbing them of their childhood? Sorry, I'm in a saucy mood, but I mean, oh my God. All right, so here is x plus 1. That's what's left down there. And now what? Now I got to multiply one more time. And I'm going to have, what's x plus 1 time? X plus 1. Something tells me you can't see that. Yeah, I'm going to have to tilt down. Oh, back up and then tilt down. There you go. Okay. And then what? Then I'll put 2 lines. And we'll do that. Chunk, chunk. Nothing left to count down there. Again, any little child can do this. And, oh, wait. Let's get some more in here. Get that right there and that. Okay. And see, later on, when I start doing negatives, what if it's negative? Well, you're going to have to go to my website, and you may have to cough up a few dollars. But most of you can't even do this much. And when I said start anywhere, I meant start anywhere. Could you start here? Oh, no, we have to do multiplication tables first. Okay, fine. No, you don't. All you have to do is count. 5 concepts. Mathematics is a study of numbers. All we do with numbers is count. The highest number we're going to count to is 9. We never even got to 3 over here. Oh, well, I guess you could say x to the third. But if I'm counting, there was only one of them. So we never got off of this hand. We form rectangles to facilitate counting. Hero 0, no fun, get back to 1. That's it. All right. I can't make it cheaper. And I'm not going to make it cheaper. And you'll see a lot of other people that are giving other information out that, yeah, if you want the information, and it's not all, you're not entitled to all the information. I know you feel you're entitled to all the information, but you're not. And further, why didn't they teach you this in school? Why didn't they show you this in school? See, for a long time, I used to have arguments with silly people who couldn't figure out that there was a definite plan to dumb you down. The Department of Education was not failing, it was doing its job. And now you were, well, I don't know about you watching, but many of your compatriots were so dumbed down that they wore a mask while they were getting injected for the thing that they were wearing the mask for. And we were the crazy ones. Okay. Anyway, any little child can do this. This is just one problem. I can play with this all day. I can just screw around with these all day long and have a fun time. And learn all manner of mathematics and count. We can learn add-ins and maybe we could do some multiplication if we made them bigger. Oh, let's do this just for fun. Let's flip the blocks over, as we say, or flip these manipulatives over. And now, instead of this being x, that's a 10. So, oh, and I'm even going to do it the long, silly way where we do expanded notation. They almost never do expanded notation anymore. But so this is going to be, well, let's move all the way over because I'm going to need it all. 10 plus 1, because I know x is 10. And then, so what's this going to be? And do you know what the name for 10 plus 1 is? I believe most of you adults do. And then what's this? This is 1,000, 2 hundreds, 2 tens, and a 1. I'm doing this right here. And what do I get when I do that? Well, I get... Oh, oops. That's the whole thing. I gotta just do this one. I got ahead of myself. 100 plus 10 plus 1. And that will give me... I got these guys running into each other. And that will give me... Where can I put an equal sign? I can't put an equal sign because I got too much stuff going on. All right, fine. We gotta get smaller. Let's get small. Let's get small. All right, now we're happy. And then I'm gonna have 100 plus 10 plus 1. There you go. And then I can put an equal sign. And now I can say, what do I have? Well, what I have is 10 times 100, 10 times 10, 10 times 1, and 1 times 100, 1 times 10, and 1 times 1. And that works out to 1,000. And I'm going to do it again in expanded notation. Plus 200s. I'll be fine. Plus 2 tens plus 1. Now, and we'll leave all of that here. So this page looks nice and mathy. I'm just going to cover it with symbols. All right, so over here I'm going to say, oh, look, that's the same thing as 11. And I'll do the division over here just for fun. And do you know what that number is? Yeah, 1,221. See, it would be silly to write it out like that, wouldn't it? See, what do they learn when they're... place value. The green ones go here. The red ones go here. The blue ones go here. And the little green ones go there. And now I can say, look, how many 11s in 1,221? 111 of them. And then what? Then I'm just going to do, well, here, we'll start here. What's 11 times, what's that? That's 100, right? That's not 1, that's in the hundreds place, and that's 100. So 11 times 100, oddly enough, is 1,100. Oh, look how hard it is! So hard. And then let's see. I'm not going to. I'm just going to count. Right? Here's what I did. I counted 1,000 and 100. There they are. Because right now I just changed the names. Okay. So what's left down here? 121. I'm not looking. I can't do subtraction. I'm just counting over here. 100, 2 tens, 1. 100, 2 tens, 1. And I could do expanded notation over here, but I already did it over here, so I don't feel like doing it again and being silly. All right, so that's what's left. Oh, now, what's 11 times 10? 110. Oh, wait. Yeah, let's put that right there. I'll tell you what. We'll do this. And then we'll move that over. Ooh, look how mathy I am. I'm so mathy. It's mathing. I'm mathing over here. All right, and then what's left? One of those and one of those. I know that's a 10 and that's a 1. All right. Now, what's 11 times 1? Oh, yeah, 11. What's left to count? Nothing. Oh, look, we just did base 10 mathematics instead. You guys can try and tell me it's hard, but it's not. And it's ridiculous that this stopped people from being engineers, stopped people from being nurses, stopped people from being lots of different things because they failed the algebra. And could I change this to A's? Could I change, right? That could be A squared, 2, excuse me, that could be A cubed, 2A squared, and 2A. Oh, let's change it to Y. Anyway, does the variable matter? The variable does not matter. And then we could have 2 variables if we wanted to, but right here we only need 1. But if we wanted to get crazy, I could call that a Y squared. But I'm not gonna. But anyway, the idea is easy as pie when you know what you're doing. And most of the time when I'm scrolling along on Facebook, the people can't even get this thing. They can't get the across and up for multiplication and the across and down for division. This is, let's be, see, like I said, I'm going to just put lots of symbols so I can take a screenshot and maybe put it on my website or something. This is division. This is multiplication. Like I said, most of them can't even do that much. And I was trying to teach this one mom, and she just couldn't figure out that, oh no, this should be, we should draw. Anyway, this is the, let's do it one more time. This is the across, across, x plus 1. This is the down, I'll put it over here. And the down is x squared, x and 1. And over here, this is the across, 11, and this is the down, 111. And this is just a rectangle, and these are the sides. Over here, do I have room? Yeah, I'll put it in here since I kind of went up a little bit. All this is, I'll put it in a straight line, 11 times 100, oh, let's put them both in there, 111, oops, set up lazy English, 11 times 111 is the same thing as 1,221. Oh, you shouldn't show this to 6-year-olds. You'll damage them. Or maybe we'll prepare them so that they don't fail when they get to high school and college and be like my one boy who went down the GED path, and when he took the practice exam, got 100%. And then when he took the test, due to some stress and other things, I think he got 1 or 2 wrong. But it was never a question of whether he was going to pass. It was a question on how high the A was going to be. How'd you like to have that situation for your children? Well, you got to start early. Don't start when they're freaking 17. Maybe you want to start when they're 3, 4, 5. And so you're trying to get people to understand that you got to get them when they're 3, 4, 5, because if you're past 7, most of you have already failed because you don't understand that language acquisition starts to end right around 7. So the time for rote memorization passes. And then by the time they're teenagers, they don't want to be memorizing multiplication tables. Certainly by the time they're 12. By the time they're 10, we're already past. Fortunately for me, I started getting it a little bit younger. But again, the mathematics, when it came to, say, fractions, yeah, I didn't understand that. I had to go to summer school. Although I have to say, once I had a teacher that could explain it to me in not just out of a textbook, some guy named John Proud at a school called Seabury Hall, it wasn't like it took one day, like one class, and I was like, and my mom couldn't believe it because she put me to summer school thinking that it was going to take all summer, and the one thing that I needed was the fractions, and I had it down like in a day once I understood that. So anyway, you can go to my fractions page, you can go to my advanced algebra page, you can go to my regular algebra page. I have 2 algebra pages, one with the module 3 and one with the module 4. The passwords, like I said, I might do a Christmas in July, probably not, but maybe I will. We'll see. I have a couple of people that were like, I missed the super secret sale, and I was like, yeah, I know. I told you it was going to be a stealth sale, and it's already over. Right? Most people missed it. And then I had 5 classes for the people that took advantage of the sale, and none of the people that took advantage of the sale came to the 5 classes. Anyway, those 5 classes are now in the can. I have work to do. I got to put them up on my website. They're going to be at the crash course page. 2 of them are there now. One of them is at the super duper super secret math page. I will download. One of them needs editing. So it may be a while before that one shows up, but it'll be pretty easy to edit, I think, because I have simple. Oh no, I don't, because I've got this computer and my other computer is in the shop, and until I get that computer back, I don't have the ability to do the editing that I want to do, because a brilliant guy in a mask who was mad at me for showing up outside of his house with my computer decided that he would take the hard drive in here, and instead of it being 500, he would turn it into 250, and then this is basically a machine that can do email and browse the web. Anyway, tired already. Okay, CroutonRamon'sHouseOfMath.com for more, but there will be more of this. All you got to do is check out Advanced Algebra on my website, and I think you'll see that, like I said, you can start anywhere. You can start in third power algebra, and then I'll make another video, and we'll play with this one, and then I'm going to challenge any Montessorian to tell me that their methodology for teaching fourth power and this methodology for teaching fourth power, put them side by side, ask any student which one makes more sense, which one is easier to grasp. They respond 100% of the time. And yet you cling because you're trying to say that, oh, this is Maria. Maria trained Mario, Mario trained Jerry, and Jerry was a clinician that figured out how to make manipulatives to explain various math concepts and make them easy. This is a huge progression from where it started out with the Cuisenaire rods. And then I have silly people trying to tell me that the Cuisenaire rods are superior. That's because you've never taught a math class in your life. All right, Crouton Ramon's HouseOfMath.com for more.